Hey, good morning, all of you. So in the previous class in friction, we are discussing the three-block problem. Just why we discussed one problem based on the three-block system. And before that, we discussed about two-block system, right? Now let us see some more problems based on the three-block system. And so now the case will be like uh, this is the given problem here. Note down that figure, and in that mention that find, that means everything is shown there, friction between 1 kg and 2 kg, like I will give some names here. So this, let it be A, B, C. So this middle block I am writing it as B. Find the maximum value of F, the maximum value of F such that all the blocks will move together. All the blocks will move together without any relative slipping. Without any relative slipping. Next, find the minimum value of F, minimum force F at which slipping starts between all the surfaces. Between all the surfaces. Next, find acceleration. Find acceleration and frictional force acting between different surfaces when F is say 10 newtons. Yeah, F is 10 newtons, 18 newtons, and when F is 15 newtons. That means for these three values we need to calculate accelerations and then frictional force between the different surfaces there. And so now our first question is like what is the maximum force that can be applied on the system such that all the move together with the common acceleration, that means without any relative slipping. So for that, generally we know in such a problems first we need to calculate this limiting frictions, and here that limiting frictions, and then we need to calculate the maximum possible accelerations of the blocks on which there is no force. So right, so first I am doing the calculation here. So that limiting friction here I am naming it as this is F1, this friction, and this is F2 I am naming here. So that F1 limiting value I am calculating here. F1 limiting is 0.5 into 1 into 10, that means 10. So it is 5 newtons. And F2 limiting value. So F2 limiting is 0.2 into 3 into 10. That means it is total 2 plus 1 into 10. And so it is 6 newtons, right? And then next what I am doing is here is the maximum possible acceleration of 1 kg and this 2 kg block C I am writing here. So that maximum possible acceleration of A, block A. So can you say how to find maximum possible acceleration of this block A? This block 1 kg block or block A is accelerating because of this frictional force only here. So the maximum frictional force is nothing but 5. And so that what we can write is the maximum acceleration of A maximum value is F1 limiting by M we can write. That means mass of this block A we can write. So which is 5 meter per second square. Is it clear? And then next similarly let us write maximum acceleration of this block C, because on block C also there is no direct external force acting on the system. Only friction should accelerate that block here. So similarly I am writing here maximum possible acceleration of block, this is block C. The maximum possible acceleration of block C. So this value similarly you can write this as AC maximum is equal to, for this maximum frictional force is F2 maximum here by mass of this block C. 6 by 2, so you will get 3 meter per second square. And so now from this what we are going to conclude here is For B, here we are calculating only for this A and C here. For B, we are not calculating because the acceleration of that B, anything can be possible depending on this applied force F here. If you goes on increasing this F value, then acceleration of this block C also goes on increasing there. So that means there is no any maximum limit for this acceleration of this block B. So that we are not considering that acceleration, maximum possible acceleration for this block B. Now here our aim is, our first question is to find the maximum force up to which all the three blocks will move with the common acceleration. So the maximum possible acceleration of this 1 kg is, that means A is 5 and 5 meter per second square, and that of C is 3 meter per second square. So that means in this comparison, to get the maximum common acceleration, the maximum common acceleration is nothing but the acceleration of the block with the least value. That means here this is the C is having that least acceleration here when compared to these two. And so now this should be the maximum acceleration of the system, because for the system, if acceleration is more than this 3 meter per second square, then A cannot get that acceleration there. Then there will be slipping between block B and block C will take place. Is it clear? So that means now the maximum possible common acceleration of the system is nothing but 3. If acceleration is more than 3, these two can move together up to that 5. But the block C cannot get more than the 3 meter per second square there. So the maximum common acceleration is nothing but, we can conclude it as 3. So therefore what we can write is, therefore maximum common acceleration of the system is, common acceleration of system is, so this is 3 meter per second square, we can conclude here. Is it clear? The maximum common acceleration of the system. And as the ground is smooth, now this value we can write this as, therefore this A value I can write this as F by like MA plus MB plus MC, you can write here, or which is 3 meter per second square. And therefore this F is equal to the mass of these blocks, you can write here 1 plus 2 plus 2 into 3. So therefore this is the maximum force until which this common acceleration is possible. So that means until 15 newtons. So that is our first question here. Until this 15 newtons, all the blocks together can move together here. Is it clear? When the force is less than 15 newtons, all the blocks can move together with the common acceleration there. So this is the maximum force until which all the blocks can move together. And next, suppose I am taking the case like they are asking like when the minimum force at which the slipping wheel starts. The minimum force at which slipping wheel starts. So slipping wheel starts means, then what we can conclude here is, if you are taking for example, so if you are taking like an example of if the force is more than this 15 newtons, if I consider here, if the more than 15 newtons, that means our question is like slipping between all surfaces should take place here. If only if the any one of the block if they ask, then again this is nothing but the minimum force here. If F is slightly more than this 15, for example 16 newtons if we consider, then what we can conclude here is there will be slipping will starts between block C and block B. So but there won't be any slipping between 5 kg and this A and B, 1 kg and 2 kg. So now our question is the minimum force at which slipping will starts for between all surfaces. That means there should be slipping between these two blocks also. That is our question here. And so this will be, we already calculated here. If force is slightly greater than this 15 newtons, there will be slipping between this block B and block C. So to get this slipping between this 1 kg and 2 kg, what we can conclude there is the maximum possible acceleration of this block A you may consider here. The maximum possible acceleration of this block A is nothing but, we can say that 5 meter per second square. So then if this system is moving with that acceleration more than that, if 5 or more than that, then you can conclude that there will be slipping between these two blocks also, we can conclude here, right? So that means now what I am taking here is, these two blocks now I am taking here 1 kg block, that means this is block A, and a block B I am taking here, which is 2 kg block, and here we are applying a force of F, and now there will be slipping. Slipping is already taking place between these two cases here. That case we are taking there, and so that force will be 6 newtons will be there in backward direction here. Now this acceleration should be equal to this 5 meter per second square, we can conclude here, right? If that value is 5 meter per second square, then the system is ready to slip. If it is slightly greater than that 5 meter per second square, then slipping will start there. So that means we are taking that acceleration is 5 meter per second square, because we are calculating that minimum force there. So minimum force means then 5 meter per second square we are taking here. And so that what I can write here is, so F minus 6 is equal to 1 plus 2 into 5. And so then this is nothing but F minus 6 is equal to 15, or F is equal to 21 newtons. So that means this will be the minimum force here. Minimum force at which slipping will start between block B and block C, or block A and block B also. Is it clear? So between block B and block C, the slipping will start once the force is greater than or equal to 15 newtons here. But the slipping between A and B will take place when the force is 21 newtons. Our question is the force at which the slipping will take place between all contacts. So between all contacts means then that force should be equal to 21 newtons there, right? So that 21 newtons is the minimum force at which the slipping will take place between all contacts. Between B and C slipping will be there, and between A and B also slipping will be there for this frictional force. And so next our question is like, they are giving some particular values of this F, and they are asking that accelerations of this block A, block B and block C and the frictional force between them. And so with these two values, now we can easily conclude about these situations here for these forces. So now you can observe that when the force is 10 newtons, now the 10 newtons is less than this 15 newtons. So less than 15 newtons means what we can conclude is all the three blocks will move with the common acceleration there, right? So that is our conclusion here for this 10 kg force, 10 newtons force. So that means here if F is equal to 10 newtons. So for this case we are discussing there. So that means this 10 newtons is less than F maximum here. Therefore what we can conclude is all blocks move with common acceleration. All blocks move with common acceleration. And therefore the common acceleration is nothing but 10 by 1 plus 2 plus 1. So this is 2 plus 2. So this is nothing but 2 meter per second square. This system here, all the three blocks are moving with this common acceleration, and a corresponding friction you can calculate there, right? But means if 1 kg block, if you are taking here, for example, I will just mention this frictional force also. If you are taking this block A, for example, it's F1 and it is moving with an acceleration of 1 meter per second square. That gives our F1 value. And if you want to calculate this F2 value, let us take the block C, then you can calculate that F2 value easily. So then this is also accelerating with 1 meter per second square. And so that this F1 value we can write as 1 into 1. So 1 Newton you will get MA. M is 1 and this A is also 1. Sorry, A is 2, not 1. This common acceleration is 2. So that this is 2, and so then this force will be, frictional force will be 2 newtons, which is less than our limiting friction, 5 newtons. And so then similarly this F2 is equal to 2 into 2. This block, mass of block C is 2, and now this is also 2, and so that this will be 4 newtons you will get, so which is less than that limiting friction. Next, similarly you can calculate for this 18 newtons here. So now 18 newtons is important here. So 18 newtons, now we can observe that it is more than this 15, but it is less than this 21. This 18 newtons, when you are considering about this force here, when you are discussing about when applied force is 18 newtons, the important thing you should observe here is this 18 newtons is greater than this F maximum, but it is less than this F minimum. So from that your conclusion is, for when the applied force is 18 newtons, there will be slipping between B and C, but there won't be any slipping between A and B. That is our conclusion there. And take the corresponding free body diagrams and then find the friction and accelerations there. Is it clear? For C separately we need to take that free body diagram, and the frictional force acting on C is now limiting friction, so which is 6, and so the acceleration of C will be 3 meter per second square you will get. But for A and B they will move with the common acceleration, because that force is applied force is less than that of this, and so then take A and B together as a system and then find the acceleration of the system. Is it clear? I am not doing that calculation, so solve that. And then next for this 25 newtons also, when the force is 25 newtons also, then what we can conclude here is all the three blocks there will be slipping between all the contact surfaces then. So because this value is 25 newtons is greater than this F minimum here, so that means when applied force is 25 newtons, slipping will take place between A and B also. So slipping takes place between A and B also. All the surfaces are moving separately, so automatically the limiting frictions you will get for this C and A. So the acceleration of A will be 5 you will get, and acceleration of C will be 3 you will get, and acceleration of B value now you need to calculate there by taking free body diagram of that D, right? So do that calculations also, right? So that is one of the problem based on this friction here, 3 block system. So now let us take one more problem here. Based on this 3 block system. So this is say 18 newtons I am taking, and this is say 100 newtons force, and this is 15 newtons. This is M1, M2 and M3 let us take. And so then M1 is equal to M2 is equal to M3. That means all the blocks we are taking them as same. And so then this value is 10 kg, mu s is 0.3 and a mu k value is 0.2. This is for all surfaces here. So for all contacts these values are same and mass of the blocks are shown there. So that means here the important thing you should observe here is there is friction between ground and this lower block also here. In 3 block system, now we are taking the case like there is some friction between lower block and then this ground also. And so as I said, even in case of 2 block system, if such a friction is there, you should solve the problem some carefully there. So in that first let us calculate the limiting frictions, and as the kinetic friction coefficient is also given different, so calculate this kinetic frictions and limiting frictions for all contact surfaces there. So here I am taking this friction as F1 and this is F2 and this is F3, right? So that means F1, F2, F3. Now I am writing this F1 limiting. So F1 limiting is 0.3 into 100. This mg, m is 10 and g is also 10. So this is 30 newtons. Next, for the same surface, the kinetic friction we are calculating here. 0.2 into 100. So which is 20 newtons. And next, similarly this F2 limiting. F2 means here, so this surface is 0.3 static coefficient of static friction, and this will be 200 you will get. That means 2 mg, 20 and g. So this will be say 60 newtons, and F2k will be kinetic friction will be 0.2 into 200, so which is 40 newtons. And similarly this F3 limiting you can write this as 0 into 0.3 into 300. Here the normal reaction, weight of 3 blocks we need to consider. So which is 90 newtons, and then this F2, F3 kinetic 0.2 into 300, so which is 60 newtons, right? So these are these values here, limiting kinetic friction for the different contact surfaces there. And so now first let us discuss about lower block. That means in general when the friction is there between the lower block and the ground, so first we need to conclude whether the lower block is able to displace or not. That means whether it is moving or not. So for that let us consider about this lower block here. So now I am taking this for M3. FBD of M3 we are taking and we are discussing about that M3. So this side is applied force 15 newtons is there here, and see the remaining forces there. Can you conclude the friction here? Frictional force. So that means now this F2 will be there. F2 because here larger force 100 newtons is acting on this block. So this block has more tendency to displace towards right, and so then F2 on M2 will be in backward direction, and so on M3 will be towards right. So this F2 will be acting along this direction, and so as F2 value is like greater than this 15 newtons, F2 limiting will be 16 newtons is acting there. So that means then because of this force, even though 15 newtons is acting this side, this block has tendency to move towards right, and so the friction at the lower surface will be towards left. So this F3 value will be acting like this. And so now from this we need to conclude that whether this under action of these forces, is there any possibility for the displacement of M3 or not. So in two block problem case also we discussed some of the problems when friction is there at the bottom. And so now here the acceleration of this block or the moment of this block is possible when this F2 value is greater than that of F3 limiting, if this 15 is not there, for example. Now as the 15 is acting, to displace this M3 value, F2 value should be greater than that of F3 limiting plus 15. Is it clear? That means what I am saying here is, and I will directly mention here, to displace M3, F2 should be greater than 15 plus F3 limiting. But so that means this is the condition required there. The required condition to displace it is F2 value should be greater than that of sum of these two values. But F2 limiting itself is less than F3 limiting. Is it clear? F2 limiting itself, F2 limiting is 60 only, but F3 limiting is 90 is acting there. So that means F2 limiting, even if you are taking the maximum possible friction of this, that will be less than that of F3 limiting itself. And so that the block M3 will remain at rest. Is it clear? The block M3 will remain at rest. Therefore, block M3 remains at rest. So it doesn't move here. That block will remain at rest, and so that F3 value will adjust accordingly, so that it will keep the system at rest there, right? And so next let us think about M1 and M2 there. So now we are going to, this is the M3 conclusion there. M3 conclusion is M3 block will remain at rest, we are concluding there. Now we are moving on to the M1 and M2. So once M1 and M2 if you are taking, we assume that they are moving together with the common acceleration, and that whether that common acceleration is possible or not, now we will decide here. And so now you can calculate the frictional force also here. For M3 let us complete all the calculations first. And so as M3 remains at rest, then there will be some slipping between these two blocks here, and so that frictional force, because this 100 newtons or this the resultant force acting on this M1 and M2 will be greater than this F2 limiting here. From that I am concluding the resultant of these two forces. So which is 82 newtons net force is acting on M1 plus M2 system this direction, right? But F2 limiting, here the limiting opposing force is only 60 newtons there. So that because of 82 newtons the system M1 plus M2 can accelerate along this direction. So with that assumption I am saying here. So once if this system is M2 is slipping on M3 here the friction will become kinetic friction. That's what I am taking here, F2K. And this side the forces will be 15 newtons will be there, and then this F3 will be there here. Therefore here F3 value now you can write here, F3 value is equal to F2K minus 15 you can write. So this value F2K is nothing but 40 minus 15. Therefore this F3 value is 25 newtons. So that is the friction between the M3 and the lower block here. M3 and lower block is only 25 newtons is acting there, which is a static friction. And next let us come to the M1 and M2 block. So M1 and M2 we can write this as, so M1 and M2, let us assume that they are moving together now. So now let us assume M1 and M2 are moving together. That means together in the sense there is no L2 slipping between them. Then that problem calculation will be similar here, similar to our even two block problems also. So that I am taking this as and this is 18 newtons is acting this side, and so here this frictional force will be there F2K. So that F2K is 40 newtons is acting this side. So this is M1 and M2. Now we are assuming that they are moving with some common acceleration AC. Therefore now that common acceleration I am writing here, that common acceleration is nothing but 100 minus 40 minus 18 by this M1 plus M2 is 10 plus 10, because all the mass of the blocks we are taking as same 10 only. So you can take like this. Therefore this AC is equal to this is like 60 58. So 58 means then here it is 42 by 20 you will get, right? And so this is 2.1 meter per second square, the common acceleration of those two blocks. So the 2.1. Now next our step is, so now we need to verify whether this common acceleration is possible or not, or for this common acceleration what is the frictional force developing here. That friction should be less than that of this limiting friction there. Then if it is less, then our assumption is true, otherwise there will be slipping between M1 and M2 also. Then again separately free body diagram we need to consider and separately we need to solve. So let us check that. So now I am verifying this. Now FBD of only M1 I am taking here. So if you consider only FBD of M1, so this side 80 newtons is acting here, and this side that static friction will be there F1, and now there is some acceleration of common acceleration of 2.1 meter per second square. Is it clear? Only those are the forces acting on this M1 block there. And so now just let us write force equation and find this F value here. So therefore this force equation is F minus 18 is equal to 10 into 2.1, and so therefore this F1 is equal to 18 plus 21, the 2.1 into that. And so then this value what we are getting here is 39 newtons we are getting there, right? So 39 newtons means then that value is greater than this F limiting. So if it is less than that 30 if you are getting for example, then common acceleration is possible, and so that this is the acceleration of this M1 and M2 you can conclude. But now we are getting the reverse case, that means our assumption is wrong. So then now you need to take the separately free body diagram and you need to solve that. So that means now, so I will write here so but F is greater than this F1 limiting, therefore our assumption is wrong. Assumption is wrong. So that means there is some slipping between M1 kg and 1 kg and M1 and M2 we need to conclude here. So that means now I am taking this free body diagram separately here, M1 and M2 free body diagram separately, and then you can write the accelerations of the system here. So for M1 free body diagram, if I consider 18 newtons is acting this side, and this side frictional force will be there. How much friction we need to consider? Now it is 20 newtons we need to consider, because we are concluding that slipping is there. So once the slipping is there, here kinetic and static both are different values are given. Now definitely you need to consider this kinetic friction only. And so this kinetic friction value is F1k value is 20 newtons only, is acting along this direction here. And so that this will be moving with some say acceleration 1. Now we can write this acceleration of that block there. Therefore this A1 is equal to 20 minus 18 by 10. So it is 0.2 meter per second square. So this is acceleration of this first block or M1 here. Now similarly find the acceleration of this second block there, M2. So now let us draw this FBD of M2. So now I can draw this FBD of M2 as, so now on M2 this 100 newtons applied force is there along this direction here, and this limiting friction, the reaction force from this M1 will be 20 newtons is acting in backward direction, and the reaction force from this M3 will be there, that is again F2k. So F2k is 40 newtons is acting along this direction here, right? So that means now this friction is 40 newtons is acting here, and this friction 20 newtons is acting along the direction there. And so that what we can write here is this is accelerating here with acceleration A2. Therefore this A2 is equal to 100 minus 20 minus 40 by 10. And so therefore this A2 is equal to, this will be 40 by 10, so 4 meter per second square you will get. So that will be the acceleration of the system here, right? So those are the accelerations of the blocks possible there. And so next let us take one more problem based on this block on block, so that you will get the more clarity about this. So I am taking that system like this, 4 blocks are there. 4 blocks in the sense to keep on, that means similar to that of actually 2 block system here. So this is connected by a string like this. So this will be the situation here. This is a capital M, small m, and this is again capital M and small m. And here we are applying some force F, and this is a smooth surface here. And so here this that static friction coefficient of static friction and kinetic frictions are given there, so that you may consider this as some mu k comma mu s, and here also that same mu k and mu s values are given there, right? So then that is our you may consider that both of them are equal, or otherwise you may consider them as separate also. Let us take only that one, let us take here. So I am taking for simplicity because in this numericals are not given, just I am giving the symbols here. So let us take the just coefficient of friction as mu. Yeah. Now find this what is the maximum value of horizontal force F so that all the blocks will move together. That is our question here. Find the maximum value of F so that all the blocks will move with the common acceleration. So now previously we discussed when the blocks are placed one above the other, we discussed the common acceleration. So now here in addition to that, there is some connection is there between the blocks here, between the two different systems actually. So now our condition is all the blocks should move with the common acceleration. That means these two blocks and these two blocks, total 4 blocks will move with the common acceleration there. So that is our question here. So can you think about this, how to solve this question here? So just to take the free body diagram of the individual blocks so that you will get the clarity about that, how to solve this problem. It's actually easy question only. Just to take the free body diagram of all the blocks here. So I will give some names here so that we can name them. This is A, B, and this is block C, and this is block D I am naming here. So now first I am taking this FBD of A and B. Right? And so we are taking that maximum force there, so that here I am taking this F1 limiting friction we am taking here, F limiting. And so now on this block some tension will be there along this direction, and this will be F limiting will be there along this direction, right? So this will be the situation for this A and B. These two blocks we are calculating here. As we am calculating this maximum force here, so that here maximum limiting friction I am taking there. They are moving with the common acceleration here. So it is assumption what we are taking here. So its acceleration is A, and this acceleration is also A we are taking. And now for this C and D, let us consider now this for C. This force will be there along this direction here, tension, and then now the friction will be there along this direction here. And now this is for M here, capital M, or which is block D, we are naming that. So now this is accelerating with acceleration, that means it is only frictional force should accelerate here. Now this block should also be accelerate A, and acceleration of this block D should also be that A only, right? So that the acceleration of all the blocks is A. So the important thing you should note here is, here we are taking that acceleration as that means the frictional force as not the limiting friction here. We are just taking that some static friction we are assuming that, right? And so that the acceleration of here, if you are taking this, for example, here also if you are taking this limiting friction here, this acceleration may be different there, because here also limiting friction and limiting friction both are equal in numerically same here, because we are taking that same coefficient of friction and same normal reactions will be there. But here the situation, the force is different here, and so that here we are taking some limiting friction. We are taking that friction as some limiting friction there. And so now just like the accelerations of all the cases, and then let us equate them, then you will get this maximum limiting friction there, right? So for this what I can write here is, for the block D I am writing here for C plus D. For C plus D system I am taking directly here for this system, right? So for this system only this tension is an accelerating force there. So that the tension is equal to T is equal to M plus M into A. This is a force equation for this C plus D. Let's suppose say this is our equation 1. And then next let us take this for B. For B, let us take this free body diagram and let us write, we already mentioned the free body diagram. Just I am writing the force equation here. F limiting minus T is equal to M into A. Therefore, this F limiting is equal to T is M plus M plus MA. That means this T value I am substituting here already. So here already MA is there, then T plus MA you will get. So T value I am substituting from this. Therefore, this F limiting value is nothing but M plus 2M into A. And so now for this block A, you can take the, so for block A, if you take the free body diagram, already here we mentioned that free body diagram, let us write the force equation here. So that this is F maximum minus F limiting is equal to MA. So that F limiting means you can substitute this value here. Therefore, this F maximum is equal to M plus 2M into A plus MA. And therefore, this what we can write is F maximum is equal to 2 of M plus M into A you can write. And so now let us take this as equation 2 here, this equation, and this equation as 3 I am taking here. Now just let us observe that equation 2, this is the for limiting friction we are getting certain value, and we can write that limiting friction in terms of the coefficient of friction there. So from that we can eliminate this value here. So what I can write here is from equation 2 and 3, from equation 2 and 3, F maximum is equal to 2 of M plus M into A. That A value you can write as F limiting by M plus 2M. And therefore this is F maximum is equal to M plus M by this is M plus 2M into this value we can write this as 2 mu mg. That means limiting friction here. The limiting friction there is nothing but mu mg, and so here already 2 is there, so 2 mu mg I am writing here. So this will be the maximum force until which all the blocks will move with the common acceleration there, right? So that means if you are applying this amount of force or less than this, then all the 4 blocks will move together with the common acceleration there. So once if this force is more than that, then the acceleration of this block will be different and acceleration of this block will be different and acceleration of those blocks will be different there. That means the common acceleration situation won't be there. Just if you are applying, if you are increasing this force here, then acceleration of this block only will increase, because here if F is increasing, then this limiting already will reaches its maximum value, so A value will increase. Because of increasing this value, there won't be any further increase in this FL value, so that this FL value doesn't increase further, and so acceleration of this small m cannot increase that further, and so that that means that will be the possible situations there, and so that means there will be some slipping between A and B blocks will take place there if you are applying friction more than that, right? So that is a way of solving this block on block problems here, and some other general problems will be there. I think all of you can solve those problems there. Like some general questions or the simple questions will be there like this. Those are simple only. With the knowledge of this block on block, you can solve all those questions easily. So this is a man of mass m and this is a Planck m, and this is some fixed pulleys arrangement is there here. Right? And so here this coefficient of friction is given as mu. And so now here we need to find the maximum force applied by the man, so that there is no any relative slipping between contact surface there between the Planck and this man. That means maximum force that he can apply on this rope, so that there is no any relative slipping between them. So draw the free body diagram. System is at rest only, and the friction maximum force, as the maximum force if you are applying here, because if you are pulling the system with the maximum force, then there is some tendency for this displacement of this block here. So the maximum force, so that there is no relative slipping, we are asking there. So the maximum force, so that there is no any relative slipping, means just to take the free body diagram and then you can find these values there. And so there will be some normal reaction from the man will be there, and from the ground will be there, N2. And similarly take the free body diagram for this man here. So for the man, when he is pulling the string in downward direction, then this force will be there in upward direction here. So which is nothing but some tension here. And then this normal reaction N1 will be there in upward direction, and Nj will be there in downward direction there, right? And that N1 is nothing but here N1. The system is in equilibrium there finally, and so that you can take this friction as limiting friction there. So just to balance those equations and solve that, you will get that F value, or which is nothing but our tension we need to find. And then similarly the another problem what we can mention here is so this is one block here, and then this another block is hanging to this like this. So this is small m and capital M, right? And so now there is some acceleration of the blocks we need to find here. So here the coefficient of friction, let us take it as mu 1, and I am taking this as some mu 2. So we need to find the acceleration of the block. The displacement is taking place there. So the acceleration of this block, we need to derive an expression for this. Acceleration of this small m. So find the acceleration of this small m. The important thing here is there is constraint relation also we need to apply here. The net acceleration of this block small m we need to find. For example, if you are taking this acceleration of this in horizontal direction as a1, if you are taking for example, then acceleration of this block small m will be, the small m now has two components of accelerations over there. So one component is in vertical direction and other component is in horizontal direction. So the horizontal component will be a1 only, because it is always in contact with the capital M, so that if capital M travels the distance x in horizontal direction, then small m also travels the same distance x in horizontal direction, right? And then it has another component in that means another component of acceleration will be there in vertical direction. So that component is nothing but, if it this block travels the distance x, for example capital M travels the distance x, then here this length of the string will decrease by x, and this length also decrease by x here. So that 2x should come down here only, right? And so that what we can conclude is its vertical component will be 2a will be there, twice that of acceleration of this block. So that means that is a constraint relation there, and so that its net acceleration will be root 5a, you can say. That means because both are the perpendicular components there. So then find the accelerations of that. Take the free body diagrams of the system and a constraint about constraint relation I explained already, and solve that problem also, right? So then with that I am closing this friction topic here, and from the next topic, next I will explain this circular motion, horizontal circular motion, and in vertical circular motion we will discuss it after completion of work power energy, because in vertical circular motion means conservation principles also required, conservation of energy principles also. So after completing that conservation of energy, we will discuss about that vertical circular motion. So in only I will explain about horizontal circular motion there, right? Thank you.